In an age where we can track our pizza deliveries in real time, how can a 200-ton Boeing 777 just vanish? That is the absolute core of the MH370 mystery. Today, we're going to do more than just retell the story. We're going to break down the incredible forensic investigation, a search for answers that's been going on for over a decade, pieced together from faint digital echoes and clues scattered across the vast, silent ocean. This right here is the question, the one that's driven a massive global effort for years. You know, it's not just about finding a lost airplane. It's about solving a puzzle where the pieces are hidden in radar logs, ghostly satellite signals, and the truly unforgiving depths of the Indian Ocean. For the first 40 minutes, everything was completely routine. And then a sequence of events unfolds that points to something deeply wrong. You get that final, calm sign-off, good night. And then just 2 minutes later, the transponder is manually, and that's the key word, manually, switched off. The plane is now invisible to civilian air traffic control. Then it makes a sharp, deliberate turn back across Malaysia, flying for another hour before finally blinking off military radar, way off course. Now, you'd think that after the plane went dark on all the radar screens, the trail would have gone cold right there. But it didn't. Because even in total electronic silence, the plane was still leaving behind these faint, digital breadcrumbs that would become the absolute foundation of the entire search. Think of it like your cell phone. Even when you're not using it, it's constantly pinging the nearest tower just to say, hey, I'm here, I've got a signal. Well, the plane's satellite unit was doing the exact same thing, automatically sending a little I'm still here signal to a satellite over the Indian Ocean. This happened about once an hour, just a tiny electronic whisper in the dark. So investigators took that whisper and figured out how to turn it into a map. It's brilliant, really. By measuring the precise time, down to the microsecond, it took for that handshake signal to go from the satellite to the plane and back again, they could calculate the distance between the two. Now, this didn't give them a single dot on the map, but it gave them a massive ring, a huge arc on the Earth's surface where the plane had to be at the moment of each handshake. Okay, but an arc that's thousands of kilometers long is still a gigantic area to search. So how do you narrow it down? Well, this is where it gets really clever. They used something called the burst frequency offset. It's basically the Doppler effect. You know this. It's the same reason an ambulance siren sounds high-pitched as it comes towards you and then drops as it moves away. By analyzing those same tiny shifts in the signal's frequency, they could figure out if the plane was generally moving toward the satellite or away from it. And this analysis led to the first huge breakthrough of the investigation. The team modeled two possible paths along those big arcs, one heading north over Asia and one heading south over the empty Indian Ocean. And when they checked the data, the recorded frequency shifts, that BFO data, were completely wrong for a flight to the north. The numbers just didn't add up. But when they modeled a flight to the south, it was a near-perfect match. The math was undeniable. MH370 turned south. For 6 more hours, the plane flew on in silence, sending its hourly pings. And then, one final, partial signal was received. This was the 7th and last handshake. Investigators believe it was triggered when the plane's engines finally flamed out, having run out of fuel. This final arc, what became known as the 7th arc, became the geographical ground zero for one of the largest and most difficult underwater searches in all of human history. Okay, so the satellite data gave us a place, an endpoint, but what it couldn't do was answer the most haunting question of all. Why? And this is where the investigation really splits into two dominant and totally different theories. On one side, you have the ghost flight theory. This idea suggests some kind of catastrophic event happened, maybe a fire or slow decompression that caused hypoxia, incapacitating everyone on board. The plane then just kept flying on autopilot for hours until its tanks ran dry. But on the other side, you've got the deliberate intervention theory. This one argues that the way communications were shut down, the timing of the turn, the way it flew to avoid radar, all of it points to someone with expert knowledge being in full control of that airplane. And this is where the evidence for human intervention gets deeply unsettling. Investigators analyzed the captain's home flight simulator, and on it, they found a plotted route, a route that flew south, ending deep in the southern Indian Ocean. A route that was strikingly, eerily similar to the one pieced together from the satellite data. Now, it's not a smoking gun, but it is a very chilling piece of this puzzle. For 17 long months, the entire investigation was built on these digital ghosts, on math and on theories. And then, in 2015, the ocean finally gave up its first secret, and the search shifted from data analysis to hard physical forensics. This was the moment, the breakthrough. The discovery of this part, called a flaperon, was confirmed to be from the missing 777. This was the definitive proof that the plane had crashed into the ocean. It put an end to all the wild speculation about it having landed somewhere, and it gave investigators their very first tangible clue. And after that first piece, more started to show up. They were carried thousands of kilometers by the ocean currents, washing up on the shores of Africa. Each piece, a wing flap found in Tanzania, an interior panel in Mauritius, an engine cowling in South Africa, each one confirmed the plane had disintegrated violently on impact. And they also helped scientists refine their models of the ocean currents, pointing them back toward that seventh arc. But here's where things get really fascinating and really complicated. These same pieces of wreckage seem to tell two completely different stories. See, analysis of the wing flap showed it was in a retracted state. That's how it would be for cruising at high altitude, not for landing. This supports the idea that no one was flying the plane and it just fell out of the sky in an uncontrolled, high-speed dive. But other experts looked at the damage on the flaperon and argued it looked more like it was ripped off during a controlled ditching at a low angle. And which one is true is critical, because a high-speed dive would create a huge, widespread debris field, while a controlled ditching would be much smaller and more concentrated. So that brings us to today. Years later, the search is being renewed, but this time the team is armed with some absolutely revolutionary technology that just might finally break this case wide open. One of the most incredible new tools sounds like something out of science fiction. It's called WSPR. Just try to picture a global web of low-power radio signals, constantly crisscrossing the planet from amateur radio operators. When a massive metal object like an airplane flies through one of those signals, it actually creates a tiny detectable disturbance. So by going back and analyzing all that historical radio data from the night of the disappearance, researchers believe they can literally trace the plane's radio footprint as it moved across the sky. And the results from this analysis are just stunning. The WSPR data seems to show the plane making several turns, maybe even flying in a holding pattern, over the southern Indian Ocean. It's allowed researchers to pinpoint a brand new, highly specific search area with a radius of just 30 kilometers. I mean, going from that massive seventh arc to a small circle like that, it's a total game changer. So how do you search this new, smaller zone? You send in the robots. A private company called Ocean Infinity is deploying a fleet of robotic submarines, AUVs. And these things are state-of-the-art. They can dive to 6,000 meters deep. Their sonar has such high resolution it can tell the difference between a rock and a piece of an engine. And they have magnetometers that can sniff out large chunks of metal. And this is the key. This new technology is specifically designed to overcome the failures of past searches. These AUVs, they hug the seabed, getting rid of any sonar blind spots, and most importantly, their magnetometers can detect the huge metal signature of the engines, even if they're buried under more than a decade of silt and sediment, which is a huge problem that might have caused earlier searches to pass right over the wreckage without even knowing it. You know, whether this new search finds the wreckage or not, the loss of MH370 has already left a permanent mark on the world. It's prompted some fundamental changes to make sure a tragedy like this can never, ever happen again. The biggest change is this. Because of MH370, the era of a modern airliner just vanishing off the grid is over, period. There's a new global standard now that requires all long-haul planes to automatically report their position every 15 minutes. And if the system detects something is wrong, like a sudden turn or altitude change, it automatically starts reporting every single minute. And yet, after all this time, all this technology, the biggest questions are still just hanging in the air. Was it a tragic accident or a deliberate, planned act? An uncontrolled dive or a controlled ditching? Can this new tech finally bring some answers, some closure? And what secrets are locked away in those black boxes, waiting at the bottom of the ocean? In the end, this entire decade-long effort, this incredible blend of mathematics, forensics, and cutting-edge technology, it's all driven by a simple and powerful human need. As the families of those on board have said from the very beginning, no wreckage, no end. It's a promise to the 239 people who were lost, and a search for truth that